Hey, it's Mr. Barr, and this is a quick lesson on the Pythagorean theorem. So there was a guy a long time ago, I think he was like 600 BC or something. His name was Pythagoras. He was a mathematician and a philosopher, and he figured out a connection in right triangles. So here's a right triangle. This is called a leg. A leg. This is the hypotenuse. And he figured out that if you take the legs and square them, if you go a leg squared plus a leg squared, that would actually equal the hypotenuse squared. So leg squared plus leg squared equals hypotenuse squared. Other classes are going to call it a squared plus b squared equals c squared. So what does that mean? This is only for right triangles. So if I have a right triangle, if this is a 3, 4, this would be a 5. What does that mean? 3 squared, 9, 4 squared, 16 equals 5 squared, 25. Now this was a very specific 3, 4, 5 triangle that I know the sides are going to work out like that. But if you're given any two of the sides, you can find the third side using the Pythagorean theorem. I'm going to get a calculator. You need a calculator also, one that can do square roots. Let me go get mine. All right. So here's a right triangle. And I'm just going to make up the sides and we're going to find the missing sides. So let's say that this is 6 and that this is 5. And I want to know what this missing side is. Here's how I'm going to do this. Since I've got the two legs, I'm going to go square, square. I'm going to add them together. So I call this square, square, add. Okay, so 6 squared is 36. 5 squared is 25. Add those together, that takes me up to, what's that, 61? So is this length 61? No, it's not 61. It's way too big. I need to take this thing down. I need to make it smaller. I need to take this down into like the ground, down into like ground, like a root system from a tree. So I'm going to take the square root of this, and the square root of 61, square root of 61, see it on my calculator, square root of 61 is, rounding it, 7.8. So this is 7.8. So if I have a leg and a leg, I do a square, square add, and then I take the square root. The other thing that could happen is that I don't have a leg, that I have a hypotenuse. Let's say this leg is 7. This is the hypotenuse of 12, and I'm looking for this missing leg. So if I'm looking for a leg, I'm going to do a square, square, subtract. So I go 12 squared, which is 144, minus 7 squared, which is 49. That's going to take me to 90 something, right? 144 minus 49, 95. So is this leg right there 95? No, that's way too big, isn't it? I need to take it down and make it smaller, take it into the ground, take the square root of it. Square root of 95. Right, on my calculator, I'm doing the square root of 95. You can see it right there. Square root of 95 is 9.7 with the rounding, 9.7. There we go. So if I have both legs, I'm going to do a square, square, add. If I have a leg and a hypotenuse, I need to get smaller, so I'm going to do a square, square, subtract. Okay, let's do 2 more example problems really quickly. This only works for right triangles. Okay, let's call this 10, we'll call this 5. Let's say these are about the same. Let's go with 8 and 7. Okay. Oh, that's not what I wanted. 8 and 13. So right here I have the two legs. So I'm going to do a square-square add. So this is 25 plus 100. That's 125, right? 25, 100. 125 is way too big. Take the square root of it. It's going to take me down into the 11s-ish. Square root of 125 takes me to 11 point, with the rounding, 11.2. So this distance right here is 11.2. Over here, I'm missing a leg, so it's going to be a square-square subtract. So 13 squared is 169. 8 squared is 64. Subtract those. 169 minus 64 takes me to 105. That's way too big. Take the square root of it to bring it down. Square root of 105. Get it as 10.24 with a good rounding. I'm going to take it to a 10.2. All right, there you go. Quick lesson in Pythagorean theorem. I know I didn't really go into the why it works, but hey, this is just quick. Get it done. Thanks for watching. Bye.